Session 2015, exercise number 1. So here we have collision and interaction. In order to study the collision between two bodies, we consider a horizontal air table equal to the launcher and two pucks A and B of respective masses, MA and MB. So we have the two masses launched with the velocity V1 collides with V2 initially with B initially at rest. So we have B initially at rest. A rebounds with the velocity V2, and B rebounds with or moves with the velocity V3. Now here, أهم شيء, first of all, is to organize our work. So we have two masses. We have MA, we have MB. So I have a collision. This means I have the before and I have the after. The values of the masses are given. So this is equal to 0.4 kilogram and MB is equal to 0.6 kilogram. بالنسبة للبيفور, what do I have as P? So I have V1 equal to 0.5 I, بينما هيدي is equal to 0. So I'll name this one V1 equal 0.5 I, and it's the positive direction. So I just put it as 0.5. And here we have V2, so I, بس عشان نخلي direction, equal negative 0.1 I. Now here it's 0. So I won't name it, so I'll just put it 0. Okay, vector, and here it's equal to V3 equals 0.4 I. هلا فينا إذا بدنا نغير أسمائهم and we name VA, VB, V prime A, V prime B, and then بعدين نعوضهم بحسب التسميات اللي هنا عطينا إياهم, and we can leave it also like this. So neglect all the frictional forces. The first question is determine the linear momentum P1 and P2 of A. So the system is A before and after collision. So we have before the collision, I have P1, so the system is A, equal M1 V1, which is MA, يعني V1 vector. So it's 0.4 times 0.5, and I keep the vector, so equal 0.2 I. In magnitude, it will be 0.2 kilogram meter per second. For the after, كمان عم نشتغل بالsystem A. We have P2, so this is V2 here, equal MA, but this times V2. So it's 0.4 times negative 0.1 I, which means it's equal to 0.04 I. كمان إذا بدي يعني kilogram meter per second, this is the magnitude. Now, find P3 of B, but this time after collision. So the system now is B, so هيدا هو system B, وبدي إياه after the collision. So I'll write here P3 equals MB, but times V3. So the mass is 0.6, the velocity is 0.4 I, so we'll get as answer 0.24 I. So هيك بنطلع answers that before and after. هيدا for the system A, but this is after for the system B, لأنه before is 0. Deduce the linear momentum P and P prime of the system A and B together before and after collision. So in the part B, I need first the before and second the after, but for the whole system. So the system now is A, B. Right. Before, I'll name it P. Before A كان اسمه P1, بس ال B ما كان عندها, so it was 0. So P is equal to P1 لأنه كان at rest. So which is equal to 0.2 I. After, so we'll name it P prime, كان عندي P تبع A after واللي سميناها P2, والP تبع B after سميناها P3. So P2 is equal to negative 0.04 I, and this is 0.24 I, which will give us 0.2 I. Next question, compare P and P prime and conclude. So we notice here, if we compare, so we have the before is equal to the after, وهذا is logic إنه يطلع معي هيك الأنسر. We have collision, so P equals P prime equals 0.2 I. Conclude, so the linear momentum, this means that the linear momentum of the system is conserved during the collision. Okay, now part 2. Name the external forces acting on the system A and B. We have to pay attention. We're talking, so when we name these forces, we have to pay attention to the system, mean system. The system is A and B, and I want the external forces. So when I have system A and B, let's suppose I have, this is A and this is B, so A and B. So the external forces will be the weight on A, the normal, the weight on B, and the normal. But I cannot take F done, the force done by A on B, لأنه it would be an internal force. It's done by A, which is in the system, on B. So in this case, it would be internal force. And the question is, name the external forces. So the external force is acting, okay, so on the whole system. So we have the weight WA, يعني on A. We have the weight WB on B. We have the normal reaction on A, reaction NA, and we have the normal reaction on B, which is NB. Give the value of the resultant of these forces. When I say resultant, means it's the sum of the forces. So I need to find the sum of the forces. So the sum of the external forces acting on this system A and B is equals to the weight A plus weight B plus normal A plus the normal B. Now here, if I notice that the object is moving, okay, the system is moving on the horizontal. So this means that the axis, so this is the horizontal, so the sum of the external forces, these are the external forces, the object or the system is on the is moving on the horizontal, is moving on the horizontal. This means, and all the forces are vertical, this means the sum of the external forces is equals to 0. So by doing the projection on the x-axis, it will be the weight and the normal equal to 0. Now, we continue. Is this resultant compatible with the conclusion in question number 1C? So in the question number 1C, we said that the linear momentum is conserved. So is it compatible? How do you know if it's compatible or no? So we know that the sum of the external forces is equals to dp over dt, okay, by Newton's second law. Second law. So if I have the sum of the external forces equal to 0, so this is the answer here, equals to, this means equal to dp over dt, which means if the derivative is equal to 0, means p is constant. When I say p is constant, means the linear momentum is conserved. So yes, it's compatible with our answer. So implies p is constant. This means linear momentum is conserved, which means that when the sum of the external forces is equal to 0, then the system is an isolated system. So yeah, linear momentum must be conserved. And then we verified it here. So yes, it's compatible. Now we continue. Part B, determine the kinetic energy of the system before and after. So system, we are studying the system A, B. Okay, what do I have before and what do I have after? The before, we have the kinetic energy of the system, in total is to KE. A, so سميناها 1, E it was 0. So equals half MA, but V1 square, and this is 0, so we'll get as answer 0.05 joules. For the after, KE of the system equal KE للA وللB. بس after, A we named 2, will be we named 3. So it would be equal half MA V2 square plus half MB V3 square. So which the answer will be 0.05 joules. So deduce the type of collision. Now, since we have KE before for the system equals to KE after for the system, this means that the collision is elastic. Part C, the duration of the collision is delta t, so the collision took 0.04 second to occur. Determine during delta t the variations delta PA and delta PB and the linear momentum. So the answer is just to find delta PA. Delta PA means P after minus, it's P final minus P initial, يعني P after minus P before, بس لمين؟ للA. So after we named P2. Before سميناها P1. So equal minus 0.24 I. Now for B, كمان is the same thing. It's P after minus P before, but for the system B. The P after we name it P3. P before كانت 0 لأنه كان at rest. So I get as answer 0.24 I. Part B, determine the forces FA on B exerted by A on B and B on A. Okay, so here I need to find this force. يعني هيدي الفورس ممنوع هلا تكون an internal force. It must be an external force in order to calculate it. So here I have to pay attention. Let's suppose, for example, I have this is A and this is B here. And A is doing on, so during the collision, so I did A here, and it did a collision with B. So if I wanted to calculate the force died by A on B, if my aim is to calculate this force, then in this case, I'm studying the forces done on B. So the system that I must take is only B. In this case, if I want to مجرد ما حطيت السيستم B, so صار يقول the summation according to Newton's second law, the summation of the external forces equal delta P over delta T, and I take delta P over delta T since I have an interval of time and not dP over dt. So what are the forces acting now on the system B? على B, if I want to trace the forces, so I have the external forces, I have WB, I have NB, but I also have the force done by A on B. So this is the force done by A on B. Now it's an external force and it's done by A, and A is not inside the system. It's an object that's outside of the system. So in this case, I put all the forces WB plus NB plus the force done by A on B equal delta P. Now here also it's delta P over delta T للB, okay, which we already found. So it's delta P over delta T للB. Now here we are on the horizontal, okay, so no motion on the vertical, which means that the weight and the normal become 0. So هيبقى في عنا at the end the force done by A on B in vector equal delta P. So I leave it as vector and I take delta P also in terms of vector. Vector equals to a vector. So it's 24I over delta T, which is 0.04. And then I get as answer 6I. Now also I have to calculate the force done by B on A. Now لو بدي أطلع الفورس done by B on A هالمرة, so my system now, if I want FB on A, my system now is A. I'm studying the forces done on A. So also I do the sum of the external forces equal delta P, but this time delta P for the system A. Okay, let's see what we have forces on A. On A, we have the weight, A, we have the normal, and we also have the force done by B on A. So we'll put the forces here. So we have WA, normal A, and the force done by B on A, which is equal delta P A over delta T. كمان there's no motion, so أنا ما عم بشتغل على there's no motion on the vertical axis. It's always moving on the horizontal here. So which means that weight and normal become 0, and I still have FB on A equal delta PA Okay, now delta PA كانت طلعت معنا equals negative 0.24 I, and this is over 0.04, so I get here minus 6 I. Now, the question is, deduce that the principle of interaction is verified. So here, so I write it here. We notice that, so part 2, we notice that we have the force done by B on A is opposite to the force done by A on B. And when I say opposite, yani opposite in direction, but equal in magnitude. So which means that the principle of interaction is verified.